Welcome back to VMware View 5 Essentials Training. In this lesson, we're going to be discussing View components and licensing. In this lesson, the View components that we're going to take a look at are the management servers. There's actually a set of 4 of them that we'll look at. The View Composer piece, which in my opinion is the heart of what makes VMware View really essential for business. The VMware View Agent, the View clients that you can connect from, the user experience, and a separate product that's bundled with View called a ThinApp. And then finally, we'll take a look at View licensing. So this graphic is the standard graphic used by VMware to show all the components that go to make up View and the View infrastructure. And right now, we're going to be taking a look at the View Manager component. So you can see it here circled in red, and it is really the core set of, or the heart of View, if you will, from an administration piece and from a connectivity piece within the infrastructure. So let's take a look at what makes up the View Manager. So the View Manager is the connection server, and what that basically is, it's the broker which allows the clients to be able to connect, be authenticated, and given a desktop based on their user access. So the connection server is really the key central piece that ties all the components that make up the View infrastructure together. Now, the replica server essentially is an additional connection server available for redundancy and for load balancing. And it essentially is just an exact duplicate copy of the connection server itself. And so we'll go through that in a little bit more detail. Then there's also the transfer server. The transfer server is used for local mode desktops who are wishing to be able to run a virtual desktop locally on their own desktop or system or laptop system and be able to take that with them if they're particularly a mobile client. So in this case, the transfer server plays the central piece in being able to check out and synchronize changes between the local mode desktop and the virtual desktop image, which is centrally located on the ESX host. And then the final piece of the View Manager suite is the security server. And the security server essentially allows for external access, or those folks that are coming in remotely, to be able to access their virtual desktops. So let's dive in a little bit more about the View Connection Server and its role and what it plays. So it's the first server that's actually installed in the View infrastructure when we go through the installation process. So the actual connection server that you initially set up is what's going to be considered the View Connection Server. And part of the installation process is it installs Active Directory application mode. It's an Atom LDAP database. If you're very familiar with Active Directory, it's a similar version of the Active Directory database in format in that it corresponds to an LDAP type of a database, and it actually uses a initial synchronization that we'll look at when we look at the replica servers, just like Active Directory does as well. So if you're familiar with Active Directory, that'll come in handy with that. It also provides a web-based View Administrator portal that's written in Adobe Flex. And in 4.5, it was rewritten up from the ground up in Adobe Flex and has a much cleaner, beautiful interface to be able to administer and manage the environment. Very simple, very clean. Now, there is also a web-based access for View clients. Originally, in prior versions prior to 4.5, users would be able to use this web portal to be able to access their virtual desktops and just connect directly. That's been deprecated now and is no longer there, but there is still a web access portal to enable users to download the View client to be able to connect remotely. Now, View Manager also provides the broker functionality that I mentioned earlier. So this broker piece it essentially sits in the middle and acts as a proxy, if you will, for the client to be able to get to the desktop. So it's kind of what handles that handoff. So initially it authenticates the client via Active Directory. So it checks the credentials of the user logging in from the client to make sure that it actually has an entitlement to be able to access a virtual desktop. Then once it is ensured that it actually has that access and presents that back to the client, and the client chooses to connect to one of the virtual desktops it's entitled to, the broker then associates a client to a virtual desktop and allows that logon process to take care. It also manages the life cycle of the virtual desktop pools. So as you're going through as an administrator, this is where you're going to manage those desktops. When you go through your patch update processes, refreshing of images, creation of new pools, addition or expansion or contraction of pool sizes, thin app packaging, and the whatnot happens in this View Administrator piece. So as I mentioned with Thin App earlier, it also is the location where you're going to assign applications to either desktops or pools from the Thin App repository of application packages. So as those Thin App packages are processed and are registered with the View Administrator, you'll then use the View Administrator to be able to assign those to particular desktops or particular pools. It's also got a piece of the single sign-on aspect, so that when a user signs on to their workstation locally, if you're connecting from a Windows workstation, it allows a single sign-on process that when they launch the client, they don't have to authenticate again and log in with their username and password on the virtual desktop if they're going to be using the same set of credentials. So it allows that process of single sign-on. We'll also see how this ties into the View Agent and View Client piece as well. The View Replica Server. So this is essentially just an additional View Manager instance. It's really just a copy of the existing View Manager that's already in existence. After the end of installation, it actually automatically begins the LDAP replication. Like I mentioned earlier in the connection server, the View Replica Server also uses the same LDAP Atom database based on the Active Directory model. And if you're familiar with Active Directory and its multi-master replication, that's what's going to happen with this replication that automatically synchronizes at the end of the installation process. So as you add nodes in a View Manager cluster, if you will, they're going to synchronize themselves automatically without any input on your behalf, just like Active Directory does for any new groups that are created or any modifications that happen to the Active Directory database. That's automatically synchronized among the nodes in the Active Directory cluster. The same type of thing happens here in the View Atom database as well. So any changes that are made or configuration changes that are made from one node in the cluster propagate to the rest of the nodes. The View Transfer Server. Now it's the main connection point for the local mode desktops. So local mode, as I mentioned earlier, is the ability to take and run a virtual desktop on a local laptop or PC and have all the processing happen there and essentially check that virtual desktop out and be able to take it with you offline. So say if you were in an airplane or a sales professional roaming about the country, you'd be able to take your virtual desktop with you, and then when you're back in the office, be able to synchronize those changes back up in place. So it's the data transfer point to do that check-in and check-out of the process. So anytime you need to check out the VM and take it with you, or check it back in after you're done with it, it allows the processing power of the virtual desktop to run either on the ESX host in the data center or locally with you on your laptop or desktop PC. And the View Transfer Server is the piece that handles that check-in and check-out process. And as I mentioned also, whenever you have checked out that desktop and have taken it offline and updated your PowerPoint presentation or whatever you've done while you're offline on your sales trip, when you bring it back in, the View Transfer Server is going to handle the process of synchronizing changes from that desktop that's been checked out. And also it's going to distribute those changes to the checked out desktop as well if there's anything that's happened from the server side as well. The View Security Server. So the security server essentially provides an SSL tunnel connection between internet-based clients and an internal View connection server. So it almost acts as an SSL VPN, if you will, from a client based outside of your internal network to be able to connect into the virtual desktop internally in the data center. Now, usually the security server will exist in the DMZ for best practices, and you'll want to keep it there and open up ports only to 443 to it, and then back to the connection servers internally. Now, there is a mapping that's directly a one-to-one relationship between a View security server and a View connection server. So you can load balance the external View security servers, but each security server needs to connect to an internal server directly. And so that way the path in from the internet would be from an internet client to security server 1 to View connection server 1. It would always take that same path. So there's always a one-to-one mapping. So you'd have the same number of security servers that you'd want to. You need to have the same number of internal view connection servers as well in order to have that direct mapping take place. Now, we already mentioned the SSL tunnel that connects the internet clients into the view connection servers, but there's also a secondary SSL tunnel which gets created when they go to actually connect to their desktop. So essentially the process is initially the user authenticates, and that authentication SSL connection takes place over one SSL tunnel. And then a second SSL tunnel is associated when a user decides to choose a desktop to log into once they've been authenticated. Then that desktop connection over PC over IP or RDP takes place over a secondary SSL tunnel. Now, View Composer. Circled over here on the right, this to me is really the heart of the View infrastructure and what makes virtual desktops viable for many reasons, and also just adds a lot of cost savings from an OpEx perspective as well. So when we look at the View Composer, it's installed on the vCenter server. So it actually has to be, it's an installation process which happens directly on there, and it has its own separate database that it needs to connect to. That database can reside on the vCenter server database server as well, but it needs to be a separate database from the vCenter database. And what the View Composer does is provide link clone functionality. And what link clone functionality essentially is a parent read-only disk that gets created and is essentially protected and isolated from being able to be changed or modified. And then a delta disk is linked to that parent clone. That delta disk is essentially only the unique characteristics to make that virtual desktop link clone unique. So things like a computer name, an Active Directory GUID, those things that actually comprise a uniqueness factor are going to be what's initially in that delta disk, which gets created, I think it's about a 32 megabyte size. So the delta disk is very small. The parent image is the same size as what the operating system would be. And that parent image is actually based on a virtual machine snapshot. So what actually happens is a virtual machine is created. You create a snapshot of that virtual machine, and then a link clone replica image is then cloned off of that snapshot image. Now what this does for us is a lot of different things. So there's a number of advantages that we get from using link clones. The first one and the foremost one is reduced storage requirements. So from a CapEx perspective, this is huge, because if we were to do virtual desktops and say have a 10 gig parent image, and we needed 10 of those, right? So that's now 100 gigabytes worth of space that we're actually going to need in order to provide just 10 virtual desktops. Now, with a link clone technology, you would then only have the 10 gig parent disk, and then whatever the size of each of the delta disk link clones would be, which I said they start off at 32 meg. They do grow in size over time, but it's a significant amount of reduction. So that same scenario of 10 virtual desktops, instead of being 100 gigabytes of space, would be probably somewhere closer to 15 or maybe 20 gigabytes of space. So that's a huge amount of savings in storage, which is usually the most expensive part of, or piece of the puzzle when it comes to virtual desktops. It also allows for quicker pool deployment. So if we're doing a manual desktop with just clones off of a parent template, then it's going to take and have to copy a 10 or 20 gigabyte disk every time it wants to deploy a new virtual desktop. In this case, with link clones, we're not doing that. We're only having to deploy that initial parent VM of 20 gig, and then the size of those link clones is really, really small and is done rather quickly. So the whole process of spinning up new virtual machines is much faster when it comes to link clones versus the traditional methods. Another advantage that we have is that it's easier to update and to do patch deployments. Since everything is based on a snapshot, I have my golden image, which I can actually bring up, modify, while the other link clones are currently running. So I can take an application, add a service pack or a patch, test it out in a limited deployment to make sure it's going to function properly with all my applications and all my test procedures. And then once I'm sure that that's fine, I can then change the parent VM, and to now, instead of pointing to the original snapshot 1, it can now point to snapshot 2 with that new service pack that I just added, or patch. And then I can roll that out to my end users. And if anything happens, and so perhaps I didn't do testing well enough, and found out that something did break, it's really easy to roll back, because all I have to do is point them back to the original snapshot, and everybody rolls back to the original desktop with very minimal downtime in the process. So makes your life as an administrator much easier, much more flexible. It's easier to recover from a system error. So because we're only basing these off of Delta disks, we can actually do one of the procedures that we'll look at a little bit later called refresh, which allows us essentially to shrink that initial Delta disk back to its original 32 meg requirement, and then just go from there. So that way we can get rid of some lingering issues that may be there in the image that have developed over time. Or like I mentioned before with the service pack, we can do a recompose, which is another operation to allow us to change snapshots and roll back to a previous known good snapshot that's working for us. And it also just allows us to have more consistent desktop environments. It allows us to have a smaller set of images that we're maintaining rather than thousands, hundreds or thousands of different images based on hardware type, based on user needs. So there's a lot of savings there, like I mentioned earlier, on the operational expense side. Alrighty, let's take a look now at the actual View Agent here, which, as you can see in the logo up here, that it's actually installed in the virtual desktops themselves. So it's installed on the virtual desktop. It can also be installed on a physical desktop, a Blade PC, or a terminal server that you want to use as a View desktop. So obviously those latter ones, the physical desktop, Blade PC, and terminal servers, those are kind of unique. And what that essentially allows you to be able to do is provide a centralized method for having a brokering and authentication piece of who is actually allowed to connect to a physical desktop, Blade PC, or terminal server remotely. So it gives you some control and allows you to handle risk a little bit better as to who is actually accessing those desktops in a remote fashion and control that centrally. With virtual desktops, it adds that functionality plus some more things. So it's installed in a parent VM or a template for the creation of automated pools. So the View Agent is what communicates back with the View Manager server to be able to handle a lot of the automation pieces that are happening there when we create those automated pools. It also works with the View Connection server to determine the availability of a desktop source. So one of the things that we get back from the View Agent is the View Manager server is constantly talking to these virtual desktops through the View Agent and allowing the View Manager to know what the status or the state is of that desktop, whether or not it's available or accessible, or it's got an issue or a problem. It's another piece of the puzzle that I mentioned earlier about the single sign-on. So what the View Agent does is it essentially puts in a genus shim into the operating system there to allow for single sign-on and a pass-through of those Active Directory credentials from the desktop or workstation where the user may be logging in from, and allows those to pass through into the virtual desktop so that they're not having to log in a second time. It also communicates directly with the View client for things like printing with ThinPrint, the ThinPrint driver, or USB redirection to create separate USB channels. vShield Endpoint is actually something that, though not technically part of the View infrastructure, is actually part of the vShield infrastructure, which are a couple of different components: vShield App, vShield Zones, vShield Edge, and vShield Endpoint. And so it's actually a security piece that's available to us, and it's actually installed at the hypervisor layer. So speaking of the hypervisor, all of this is running and required to run on VMware vSphere. So you gain all the same benefits of having your virtual desktops on VMware vSphere as your virtual servers do. So things like HA or high availability, vMotion to be able to move workloads across from one server to another. So all those benefits are gained by having the hypervisor VMware vSphere in place in order to run these virtual desktops. And this is another added benefit here with the vShield Endpoint aspect, because the vShield Endpoint is actually going to leverage the hypervisor to do introspection of the VMs from underneath. So when we look at vShield Endpoint, what exactly is it? Essentially, it's an enabler for antivirus and third-party vendors to be able to write their their antivirus so that there is now a virtual appliance from your antivirus vendor that offloads your antivirus and your anti-malware processing from the individual virtual machines onto this virtual appliance. So this single virtual appliance, it's per host, and it uses the VMsafe API in order to be able to do this introspection from up underneath the virtual machine. So there's a lot of advantages to this, right? So one of them is the improvement in VM performance. So now this virtual appliance will be handling scanning, updates, and the like, so that it's going to offload some of the CPU, I/O, and memory requirements from each individual virtual machine to this virtual appliance. It's also going to help prevent antivirus storms because you have this centralized virtual appliance that's aware of all the VMs running on a particular host. It has some insight into how those are running, and it also can take that scanning offload instead of having all of a sudden all your antiviruses start scanning at once across all your virtual machines and just bring your ESX host to a grinding halt. This virtual appliance is smart and isn't going to be doing that. So it's going to be scanning and accessing virtual machines in a fashion that's going to keep performance at a high level and not to degrade the system. Also, updates and signatures are only handled once on that virtual appliance per host. So instead of all of your virtual machines deciding to do an update at once and sucking down a huge amount of bandwidth across the network pipe, you're not going to have that happening with just the appliance doing that. And the other nice added feature of that as well is that this appliance is going to be scanning from up underneath the OS. So it has a better insight into the OS than an application that's actually installed on the OS. It gets the antivirus hooks out of the kernel mode area of the OS, making your operating system a lot more available, a lot more accessible, a lot not as picky as when antivirus is installed actually in the operating system, because it has to have such a tight control on the OS. So now you relieve that point, and you allow for the ability to be able to see things like rootkits and those things that try and hide underneath the operating system. So the View Client, let's talk about that. So the View Client is the heart of what the end user is going to interact with and what they're going to use on a day-to-day basis. So what do we get out of this? So this is the software that's actually installed and enables client access to a View desktop. It takes a bunch of different shapes actually, and it's continually expanding. So the most prevalent and the most feature-rich access is on a Windows desktop or laptop. We get all of the features that are available, like USB redirection, multimedia redirection, smart card access, token use, single sign-on. So all those features that we're looking at, that's the most feature-rich. Some of the other clients are lacking in those. Like they may only have RDP support instead, like the Mac OS X client, which doesn't have PC over IP support. The iPad client does actually have PC over IP support but not RDP support. So it varies between the clients. So I highly recommend you look at the client documentation guide for the feature requests based on what features you need. There's also a brand new Android client which came out with View 5. The Linux Open Client is the only one that allows you to be able to connect with Linux clients, and a lot of the thin client manufacturers use that for their implementations when they're using a Linux-based thin client to connect with. And then there are the thin client actual providers, and these are only provided to thin client manufacturers. They're not available to the public, but this allows thin client manufacturers to write a View client into their code for their XP embedded, their Linux, or their Zero client, or their own custom OS, things like the Thin OS from Weiss. So definitely check out the different thin client options. There's some really neat things out there in the marketplace that they're doing. So local mode. Local mode is a special version of the View client for Windows. It's essentially the same with some added components. Now, one of the requirements with this is that you can't actually have VMware Workstation running on your local laptop or desktop in order to install the local mode, because there are some commonalities that the local mode client has with VMware Workstation which conflict with each other. So do be aware of that. But essentially what it does is it allows you to be able to download and check out a virtual desktop, even a link clone virtual desktop now, to allow that to have local execution of that virtual desktop on your system. So it synchronizes back with the View Transfer Server whenever it's possible. And do make note that you need to be able to have enough system requirements on your local system as you do for the virtual desktop that you're checking out. So if you're checking out a 4 gig memory Windows 7 VM, and you're checking it out on an XP laptop with 1 gig of memory, that's not going to work, right? So do make sure you take a look at what your requirements are for the virtual desktop and make sure that it's at least equal or greater on the local desktop that you're going to be checking it out onto. So kiosk mode. Kiosk mode is a actual special running of the View client for a public location. So the types of thing that this is going to be based on is going to be based on public kiosks, like at an airport terminal to check in, or a guest mode kiosk for folks to be able to access in your lobby. It's a desktop that's entitled based on a device rather than on a user, because this is going to be for public use. So you're assuming that this is going to be a generic account that's going to be accessing this. So you're going to have a common automatic logon for guest access with this. And you're also going to want to have application level authentication required. The main reason for this is because this is a guest access system. It either needs to be anonymous access, like internet browsing, or your actual application needs to have some authentication built in so that there can be a challenge on who accesses it and who's accessing the application or the data. So just be aware of that when you're creating your kiosk mode clients. And let's also now look at the user experience, right? So what do people get out of it when they're actually connecting to a virtual desktop? So one of the things that they get is they get the ability to have persistent and non-persistent disks. So when we're creating virtual desktops, we have the ability for there to be persistence with the data that the people access, so that when a user logs in, they have the ability to see the same data every time when they log in and save files. And we also have a set of disks that are called non-persistent disks that allow for things like temporary storage, things like temporary internet files or log files or data that's transient that we don't care about can be stored on these separate non-persistent disks. And then when the user logs off, it's wiped clean again. So persona management, this is new for View 5, but this is the ability to control where the user profile is stored and how it's accessed. So in View 5, we now have some new capabilities that are controlled through GPO that allow the user profile to be handled in a much better way than roaming profiles or a user data disk. So there's several protocols that are also available to users to be able to take a look at. The first and most popular protocol is the Teradici PC over IP protocol. Teradici is a separate company that VMware has partnered with in order to provide this very dynamic protocol. It is made to have the best user experience possible. So when a user is connecting to their virtual desktop and whatever they're trying to access, if it's multimedia, it's going to try and build what's called build to lossless, where it's going to really try and make the experience the best possible. There's actually some wonderful new controls now that you'll be hearing about later in View 5 that have been accessed to be able to put some finer controls on the PC over IP protocol, because it is adaptive and it will take as much bandwidth as it can get in order to make the experience better. We have some better controls now in order to be able to limit the access of how much bandwidth is actually allowed to be taken, or what type of image level or image quality that we're looking at on a pool-to-pool basis. Now we also have the traditional Microsoft RDP, and this gives us the same type of access that you're familiar with your standard terminal server or remote desktop protocol. And the default protocol can be set per pool, so you can allow users to be able to choose what they want, or you can actually set what that default's going to be and control that as well. One of the protocols actually that has been removed here in View 5 was HP RGS. So if you were using that or you have need for that, you'll definitely want to make sure you stay on View 4.5 or earlier until you can provide a transition to be able to get off of HPRGS. So, like I mentioned, the end user can choose the protocol unless the option has been disabled by the administrator. So you as the administrator have the ability to set what the users are going to be able to access. There's also multi-monitor display support. So for those users that need to be able to have a 2 or 4 monitor setup, that's definitely available, and it is very much enhanced with the PC over IP protocol. So printing is also an experience that's been enhanced. The ThinPrint technology that VMware has licensed from ThinPrint helps to be able to control the compression of the print images as they're going across the wire and keeping that channel separate from the standard protocol channels to be able to allow for greater control of quality. Continuity services is something new that's been enabled here in View 5, and essentially it is the ability for you to be able to lose connectivity to your desktop for a short period of time. In the case of roaming from one wireless access point to another, and yet still being able to connect back to that virtual desktop over time. And then multimedia services as well. So there's multimedia redirection, which is set again like printing, where it's in a separate channel from the standard protocol channels, and also provides the ability for the local desktop or client to be able to offload some of the processing of that multimedia in order to provide for a much richer experience for the end user. And then we also have USB to redirection as well, which again also is another separate channel outside of the protocols, which allows for the redirection of USB media like thumb drives to be able to be accessed and controlled separately. Alrighty, let's take a look at ThinApp. ThinApp's one of my favorites and kind of unsung applications, I think, in View. So let's look at what it actually is and kind of what it can do for you. So ThinApp is application virtualization. And essentially what this is we've been seeing in the virtual desktop realm the ability to separate the hardware from the operating system, which we've done with server virtualization, right? We've broken that barrier and kind of abstracted the hardware away from the actual operating system. So we're doing kind of the same thing here with the application. So we're separating the application stack away from the operating system. And what we're really doing in the case of ThinApp is we're creating a virtual bubble for the application to run in. So it has its own virtual registry and virtual file system that it runs within, isolated from the operating systems. So that way inside of this virtual bubble, changes can take place, things can be updated, but they don't actually affect the OS or touch the OS at all. So it's executed using the local resources of the OS, but it's isolated from that local registry and file system. So any changes that happen to the registry or file system for that application, they're written to a sandbox that's specific to that particular user, which can be on a local USB drive, it can be on a network share, or it can be in somewhere like the application data folder of the actual profile of that particular user. So that way any of those changes or updates to the application get written directly there and actually don't touch really the OS itself. So because it's self-contained in its own executable and it's run from an actual network share, you essentially just launch the application, it's then streamed down and then run in its own virtual little bubble. And it's really handy and helpful to be able to keep conflicts from happening. Because a lot of the times the things that we run into problems with in troubleshooting on the desktop over and over are system or DLL issues where applications that have been installed are conflicting with each other or overriding things. So this allows them to stay in their nice little happy bubble, unaware from any other applications that may be installed and may be running. So again, some great OpEx savings that help you out as the administrator. And it's agentless. You don't have to worry about maintaining or running agents. It's simply a self-contained executable that you run from a file share. All right, let's take a look at the wonderful world of licensing. As we look at View licensing, there's essentially two main product suites. There's the View Enterprise suite and the View Premier suite. So View Enterprise is really pretty slim. You're not getting much when you get the Enterprise bundle. You get View Manager, which is the broker. So it allows you to do brokering and pooling, but you don't get View Composer, you don't get Persona Management, you don't get Local Mode, you don't get Visual Endpoint, and you don't get ThinApp. So all the real bells and whistles come in the Premier bundles. And if you'll notice in both of the bundles, they include what are called vSphere for desktops. So vSphere for desktops enables you to be able to have the ESXi host at a much reduced cost and a copy of vCenter Standard as well to be able to run your environment without paying as much as you typically would pay in a server virtualization environment. You also have the option of having a la carte vSphere for desktops purchased by itself. And really the use case for this is in case you want to run any other third-party products other than View. So if you wanted to run something like Citrix Zen desktop and you wanted to leverage that on top of vSphere, they will, instead of having to buy the full ESX licensing, standard licensing that you would pay for server virtualization, you can still buy a reduced cost license of vSphere for desktops. So that's something new that VMware's just announced here with View 5. So that's a real bonus. So we also have the add-on options. So on the add-ons, what we're essentially allowing you to be able to do is add on in 10 or 100 packs for the View Enterprise or the View Premier option. Now notice that there is a separate one of vCenter for desktops and vSphere for desktops versus just the standard add-on. So the add-on to the bundle upgrade is what's going to give you access to additional ESX hosts and additional vCenter servers to be able to use in your environment, and not just the additional clients. If you just get the View Enterprise add-on or View Premier add-on, you're just buying additional concurrent connections that you can use. Now, and one other factor to mention on the vSphere for desktops, according to the EULA, the only things that can run on vSphere for desktops are any of the View components that manage the environment, so an Active Directory server, the View Manager servers, a security server, any of those components can run on vSphere for desktops, but you can't use that for existing server virtualization workloads. Now, what you can do with the vSphere for desktops, it essentially allows you to run as many ESX hosts as you want in order to support the virtual desktop workload you need. So when you get the copy of vSphere for desktops, it's licensed per VM, not per socket like it usually is in standard server virtualization. So if I want to run an ESX host with a single virtual desktop on top of it, I can do that. That would be really kind of silly and not very cost effective, but you have that option. So no matter what your workload need is, you can run as many ESX hosts as you need to support that workload. So let's take a look at ThinApp licensing because it's a little bit different, right? So it comes with View Premier. It also is a separate a la carte product that you can purchase by itself. But when you purchase it with View Premier, you get one virtualization package or license key. Now what this key essentially is the key that allows you to run and package ThinApp itself as an application and package applications. You also get a copy of VMware Workstation. So what this also allows you to do is it gives you a really nice way to have a clean capture and build environment. So that way you can run VMware Workstation with a clean version of XP desktop or Windows 7 desktop and build your application packages in a clean environment and be able to use snapshots to go backwards and forwards as you're doing capturing to get back to that clean state, and then also to be able to test your application after you've packaged it. So you also get clients which are equal to the number of the concurrent View licenses. So however many View licenses you purchase, that's how many clients that you'll have licensed to for ThinApp as well. So the ThinApp suite includes a one virtualization package or license key, one workstation key, and 50 client licenses if you were to purchase that separately. So what did we cover today? We took a look at View components, the management servers, and those 4 servers that go to make that up, the View Manager, the Replica, the security server, and the transfer server. We took a look at the View Composer piece, the kind of the heart of View. We looked at the View Agent, the View clients, what the user experience is like, and what exactly ThinApp is and how does that fit into the View infrastructure itself. And then finally, we also took a look at View licensing and how that impacts your decision as you move forward in purchasing View. So for our use case and for our company, they're going to be looking at the View Premier licensing. So as we go forward, that's the licensing that we're going to be using, so that way we can showcase all of the View components. And it makes sense for most organizations as well. As I'm going to my clients and customers, usually most people want to get beyond just having a desktop image. They want to get some of those operational expense savings by using View Composer, by using ThinApp. So I really see a lot more of that than I ever do of the View Enterprise licensing in my experience as well. Well, thanks so much for listening, and we'll go on to the next lesson.